Hello, this is the first video of Matrices Intro to Matrices. Today, I will introduce you to matrices. Before getting into the matrices, I want to explain some applications where matrices are used. First one is solving systems of linear equations. Second one is that star x, y pairs of coordinates pixel vertices in computer graphics. Third one is that star inventory data for each star in the chain of stars. The next one is that use in transportation routing for storing connections distance between nodes in a network. And the last one is that storage and analysis of polling data. Okay, now let's start talking about matrices. We can say that a matrix is a table with rows and columns. This is matrix A. As you can see in the example, it's like a rectangular table. When we look at a matrix, firstly we think about its dimension. The dimension of a matrix tells its size, the number of rows and columns of the matrix. We write first the number of rows. After writing the number of rows, we write the number of columns like this, 3 by 4. If the given matrix has the same number of rows as it does columns, it's called a square matrix. Matrix B is an example of 2 by 2 square matrix. Square matrices are useful in that you can do specific calculations with them that you are unable to do with other matrices. For example, you can only find the determinant of a square matrix, and you can only find the inverse of a square matrix. A matrix element is simply a matrix entry. Each element in a matrix identified by naming the row and column in which it appears. For example, if we consider matrix K, the element K of 3, 2 is the entry in the third row and the second column. In this case, K of 3, 2 equals to 11. In general, the element in row I and column J of matrix is determined as A of ij. You can write them also like these. All of them mean the same thing, so that you can use whichever you want. Also, there are some other types of matrices that have specific unique characteristics. Let's start with the identity matrix. The identity matrix is the equivalent at the number 1. Every matrix will return the matrix that you started with the identity matrix. We usually represent it with capital I. There are two unique things about the identity matrix. The first one is it has to have the same number of rows and columns, so that it has to be a square matrix, like in the example. The second one is that the identity matrix is completely filled with zeros except for a diagonal line of ones down the side. This is an example of 4 by 4 identity matrix. In this example, you can see the diagonal line of ones way easier. You can make your identity matrix as large as you need it to be, as long as it remains square. The next type of matrix is called singular matrix. A singular matrix doesn't have an inverse of it. You can find the singularity of a matrix by finding its determinant. If the determinant is 0, that matrix is a singular matrix. The reason why you would want to find that matrix singular or not is many calculations require you to the inverse of a matrix. If your matrix doesn't have an inverse of it, then your calculation will fail. The example that you see is usually one of the most important singular matrices that you will come across. Usually, you will generate a random matrix to test any calculation you do on your computer, and this will be the first one that comes to your mind. However, it's a singular matrix. It won't allow you to do an inverse or find its determinant. The last type of matrix is called vector matrices. There are two types, a row matrix and a column matrix. They are also known as row and column vector. Their characteristic is that they have just a single row or a single column, as you see. Depending on how you use it, it will be referred as vector matrices. Thank you for watching this Intro to Matrices video. I hope you liked it. There will be more videos about matrices. See you again.